His dad's in Russia. Luke, this is for you. Section 6.3. We're creating and comparing quadratics. Let's go to work. Before I get into this, actually, I do want to talk about yesterday. Yesterday, Ms. Boland was not able to pull up the video for you, but you guys were all able to watch it, no problem. And then you were able to do your homework. The majority of people had it done before they left, is what I was understood. Really easy?
Yeah.
Why was it so easy, Dick? Desmos. Think about it. This whole chapter that we start talking about Unit 6, way back when we started in 6.1, the first thing we did is we took 6.1 and we said, all right, now we're going to start using Desmos. Why? Well, Chapter 6 is about quadratics, but we just spent all of Chapter 5 talking about quadratics. I mean, in Chapter 5, we learned how to graph quadratics. We learned how to factor quadratics. Then we learned how to complete the square. So as we start this one and we start saying, hey, we're going to solve quadratics, well, that's kind of doing the same thing, right? But as we get ready for our end of year, I want to make sure we don't make any computational errors because you guys know what you're doing. You did great in Chapter 5. And I want to make sure that we get everything right. Let's use Desmos. Let's use the tools that are in front of us to do the same thing that we already know how to do, just like we did on the problem of the day earlier. So 6.1, we started using Desmos. 6.2, we used the quadratic formula. Do it right, do it light, do it wrong, do it long. Let's do the quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2a. One more time, Miss Mace, for the cheap seats. Negative b plus or minus square root b squared minus 4ac all over 2a. Now that little 2a, I'm going to finish by talking about that today. Okay, I'm going to talk about that negative 2 or that 2a at the end of the day today, and I'm going to show you something really cool about it. Okay, and that's what we did in 6.2. Now I jumped over 6.3 because I wasn't with you yesterday, and we did the solving quadratics or systems where we solved more than one at a time. And you said yourself it was really easy to do. We just put them both on Desmos. We find those points where they intersect. Those are our solutions. What you're going to find in 6.5 and 6.6 is going to be more of the same. Use Desmos. It's going to show you your solutions. What are our solutions with a quadratic? The what?
Where they hit the x-axis, like where they hit the x-axis.
X-axis. So we got solutions. We got x-intercepts. What's another name for them?
Zeros.
The zeros. And finally, the roots. The roots of the quadratic. Yeah, that's what I'm after, right? Okay. So, but in section 6.3, we're going to create and compare quadratics. We're not going to be using Desmos here. Here, I want to come up with the equations given information. Can we create the equations? This is hard. Okay, this is difficult. I'm not being sarcastic. This is difficult, so I need you to pay attention today, okay? Let's start before we actually get into it, and let's remember the forms that we use, okay? Who can tell me what is standard form when we're talking about a quadratic? Who can tell me what standard form is? JC, go ahead. AX squared plus BX plus C. I don't care if you feel like you know it forward and backward. Write it down again, please. Write it down again. Standard form is AX squared plus BX plus C. Who can tell me intercept form? Go ahead, Skylar.
Parentheses, x minus p, and then x minus q.
Close. Close. A. Remember, there's an A in front. So A times x minus p times x minus q. And that is called intercept form. What's another name of that one? Factored form. Okay, factored form. And lastly, the vertex form. Someone else, vertex form. Nick, can you get it? No? No, not negative b over 2a. Ariana? Oh, come on. Haas? F of x, okay, equals Okay. Ashlyn? Quantity squared plus k. There we go. That's why we're writing them down again. All of them could be f of x equals, or what can I put instead of f of x? Or y, because I want to know. Okay. A times x minus h quantity squared plus k is vertex form. Now, if you remember way back in beginning of chapter 5, I gave you these. We took a quiz on them and we all rocked it, right? Because we were able to regurgitate that information out. But isn't it amazing how just a little bit of time passes and it starts to leave your brain? That's why it's important that you write it down over and over and over again. And that's why I keep making you write it down, okay, and giving those back. The more you deal with something, the better chance of you retaining it, right? If you don't use it, you lose it, okay? So these are what we've dealt with in the past. So now we're going to be given a situation, in particular, a table or a graph. Today I'm going to start with a table. May not get to a graph today, but we're going to start with a table. And we're going to look at that table and we're going to say, is that a quadratic? And if it's a quadratic, we're going to create the equation that the data or the table gives us. Okay, that's what we're doing today. Let's start by looking at this table. Okay. Now, if I'm looking at this table and I said way back in chapter 2 when we were talking about linear equations, we said, hey, is this graph a linear equation? Do you remember what you would do? All right, I'm going to ask this question. Is this a linear function? JC says yes. Not is it a function. All right, let's start. Let's go back to chapter 1. Is it a function?
Yeah.
Definitely a function. Why? What's a function?
One input, one output.
One input, one output. They all have one input, one output. Good. It is a function, chapter 1. Chapter 2, is it linear?
No.
Why not?
Because there's the 2 3s, so it'd be a quadrant.
Oh, so you see those and you're jumping ahead. Okay.
And the 6s.
And the 6s.
The way that it goes out.
All right, you're jumping ahead. I want to go back to this question, though. I like your thinking, and you're not wrong. Okay? Is this a linear? He says no because he thinks that he sees the quadratic in it. Why? Ashlyn?
So, because every time the x goes down, the y goes down and then.
Okay, you're saying the same thing that Skylar did. Go ahead, Skylar.
So it's not like a constant increase or decrease.
Good. When we talked in chapter 2, we had to have a constant rate of change. Remember, we found the difference between these. Let's find that difference real quick. From -3 to 6, it goes down 3, right? From -6 to -1, it goes down 1. From -7 to 6, it goes up 1. From -6 to -3, it goes up 3. So that's not a constant rate of change. It has to be a constant. Now look, this question, like what I'm asking right now, not the one we're going to be dealing with in a second, but just given a table and ask, is this a linear? Well, it's got to have a constant rate of change. I don't care how I give it to you. If I give you a situation, I say, hey, is this show a linear relationship? It's got to have a constant rate of change. Remember that. Please don't forget that. It's got to have a constant rate of change to be linear. Well, this one we know is not linear because it doesn't have a constant rate of change. We found that by seeing the first difference. Here's one I want to give you today. Look at this second difference. What's the difference between -3 and -1? Goes up 2, right? How about from -1 to 1? Goes up 2. How about from -1 to 3? It goes up 2. This is called the second difference. So if that's the second difference, what was this first one? Look at my man. So smart. The first difference. And here's what I'm telling you right now. If the second difference is constant, we have a quadratic. If the second difference is constant, we have a quadratic. Cool? Just one more thing to kind of help you remember. A linear equation is called a linear equation. Why?
Because it's a straight line.
Yes, and it's not why we name it. Like, we don't name something the second degree of parabola. Its graph is a parabola, but we don't call it a parabola. It's to the first power. We call it linear because it's to the first power, right? And if it's going to be linear, it's got to have the first degree has to be constant. Why do we call something a quadratic? Because it's to the second power. If we're calling it a quadratic, the second difference has to be constant. Maybe that'll help you make that connection as well. Okay, so if the first difference is constant, we have a linear. If the second difference is constant, we have a quadratic. See how those kind of go back together again. All right, so now we know we have a quadratic. How are we going to come up with the equation of this line, or of this parabola in this case? Because we know we have a quadratic. Well, let's go back to what we already talked about. We know these formats or forms that we have. Which one have we liked the most? Oh, you did? Which one did you like? You liked intercept? I like vertex form. Anybody else vertex form fan? No fans, huh? Oh, good one. I'm going to use the vertex form and here's why. Can I look at that table and find the vertex? Can anybody find the vertex on there? Yes.
HK.
Just in this table.
Oh,
Yes, it's
I
HK.
thought you were talking about that.
Just in this table. Which one of these points is the vertex, and how do you know?
-2, -7.
-2, -7. How many people say -2, -7? Only one person. 2 people. 3 people. 4. Oh, now we're growing. -2, -7 is the vertex. Now, how do we know?
Because you can tell.
We can tell. Look. Let me go to a different color so you can really see it. Look at that. -6 and -6. -3 and -3. Remember, on either side of the vertex, those points mirror each other. So that's what you're looking for. We're looking for when those y values start mirroring each other on either side. So they're mirroring on either side of the 7, so this has to be the vertex. All right, now since that's the vertex, I know that my vertex is -2, -7. And I know vertex form. Vertex form is f of x equals a times x minus h, quantity squared, plus k. Can't I put these values into that equation or formula? So wouldn't it be f of x equals a times x plus 2, quantity squared, minus 7? Why is it plus 2? Yes. Because it's inside the parentheses and it has to be opposite of whatever it was. So let's not forget that. You like that? Now, that's almost complete. But we don't know what A is, do we? We don't know what A is. Can we find A? That's going to be our question. Yes, we can. And here's how we find A. Take another point that you know is on the parabola. Let's go with 0, -3. 0, -3. And let's plug those in for our x and our y values, right? Because this f of x, it's the same thing as y, right? So watch what happens when I plug those in for x and y. I end up with -3 equals a times, my x is now 0, plus 2, quantity squared, minus 7. Now, there's only one variable in there. Since there's only one variable, we can solve for it. Let's simplify. 0 plus 2 is 2. 2 squared is
4.
So this becomes a times 4 minus 7. That equals -3. Well, a times 4, it looks a little hinky to me, doesn't it to you? Could I rewrite that for a? Does that make you feel better? Me too. Now what?
Add 7 to the other side.
Add 7. So I now have 4 equals 4a. Divide by 4. Divide by 4. 1 equals a. So now what is my a? 1. So now I plug that back in, and I have y equals 1, but I don't really have to write it, do I? X plus 2, quantity squared, minus 7. We just created the equation of that table. Whew. Was a lot. I told you this would be hard. Yes?
Yes.
Was you able to follow everything the first time? If you're able to follow everything, we're in a good place. Okay? Let's do it again. Okay? I promise you, this 2a is going to come back and you're going to like it at the end. Okay? Let's do this process one more time. All right? Let's look at another one. Here we go. First question. Here's a table. Is it a quadratic?
Yeah.
How do we know?
Well, I guess you have to look for a second difference.
I got to find my second difference, don't I? So let's do that. My first difference here. I want to get rid of that green. I want something that pops. Let's go with a little red here. From 16 to 7 would be minus 9, right? 7 to 4. 4 to 7. 7 to 16. All right, that's my first difference. So we know it's not linear, right? Second difference. From -9 to -6, or -9 to -3. +6. From -3 to +3. +6. From 3 to 9. +6. Second difference the same? Do we have a quadratic? Great, have a quadratic. What is my vertex?
2, 4.
2, 4. How do you know it's 2, 4?
Yeah.
With the mirrors. 7s and 16s. You see it? Okay, time out. Is it always going to be in the middle?
No.
You guys have 6-3 open, right?
Yeah.
Look at the very top table in 6-3. Very top beginning of 6-3. Everybody see it? Look on your neighbor if yours isn't open. Not there. Right there. Right there. See it? Very beginning. Find the vertex in that one for me. Raise your hand when you got it. Don't burn it out because other people quit looking. Point to it. Point to it. Circle. Circle. No.
Oh, what?
No.
Oh, sorry.
Find the vertex. What you want is looking for y values that mirror each other. See 2 y values. Yeah, you see 2 more that are the same. This is our vertex. This is how those come together. See some y values that are the same. See 2 more that are the same. This is our vertex. Excellent. Yeah, but I want you to see it here. See how those are the same? And those are the same, they come together. All right, so we're good there. So it's not always going to be in the middle. It just happened to be for these two that I did. It doesn't necessarily have to be in the middle of the table, right? You're looking for those y values that mirror each other, and you're looking for the middle of the mirror, right? That's where our vertex is. Okay, so back to the problem. We know we have a quadratic. We know where our vertex is. Now what do we use? Vertex form. Vertex form. Let's plug in the vertex that we know. We know the vertex is 2, 4. So let's plug that into the vertex form. F of x equals ax minus h quantity squared plus k. So that would be, I don't know a yet, x minus 2 squared plus 4. Everybody okay with that? I just plug the vertex that I know in. Now what? Now let's pick another point. Doesn't matter what point.
No.
Just pick one. I'm just going to go with 3, 7. Okay. Now I'm going to plug the point 3, 7 in for x and y. Remember, my f of x is y, right? So 7 equals a times 3 minus 2 quantity squared plus 4. Are you okay there? Ashlyn, you okay? Now what do? All I got to do is solve for a. So 3 minus 2. 1 squared is? So 1 times a is 1a, or just a. So 7 equals a plus 4. Subtract 4. Subtract 4. 3 equals a. Plug that back into my formula, or my format. F of x equals 3 times x minus 2 quantity squared plus 4. There is the equation of the parabola given to us in that table. Yes, ma'am.
I have a question. If the vertex was like -2 and -4, how would you plug that into the equation? Would it end up being x plus 2?
Yes.
And then what about the 4?
It would stay negative on the outside. Yes, absolutely. Remember, every time we put it inside the parentheses, we got to go the opposite of what's there. Good question. Good question. Cool? Now, remember I told you I'd tell you something about 2a? Check this out. Let's go back to this first one. Just for argument's sake, you can see my a right here is 1, right? What if I said 2a equals my second difference? Remember back when we found our second difference? What was our second difference in this first question? See it right there? What is it? Plus 2. So 2. Watch this. How do I solve for a now? Divide by 2, right? So a equals 1. What was my a? Let's look at this second one. What was my second difference? 2a equals 6. How do I solve? A equals yes. Here comes. Go ahead. Say it, Johnny. Why'd you teach us all that? So you know why it works. Really, we'll be able to jump straight from once we find our second difference, divided by 2, and that's going to be your a value. That's going to be your a value. Do I have time for one more? Yes. Let's do one more real quick. No. Let's go. No, I don't have time. Here's what I want you to do for your homework. Now look, I only talked about the table, right? So you're going to have to do a little reading. Reread that section. I know you're supposed to already have read and highlighted, but reread that section, okay? And I only want you to do problems 1, 2, and 3. That's it. 1, 2, and 3. Okay? You're going to struggle on them. It's okay. Do your best. We'll talk about those tomorrow, and we'll keep moving forward. And we'll talk about a graph specifically tomorrow. Can I get an amen? All right, Luke. Be safe coming home.